So hello to C284. Now I'm gonna go over homework number 3. I'm just gonna solve the questions and record this video for you guys. Again, gender neutral. So you can see, you can watch this, and it can help you with solving these questions. Let me start with the first question now. So this is basically an algorithm that is used by many companies to calculate how your retirement plan can work. Uh, like as an example, the algorithm says that up to annual salary of $30,000, what you can save tax free is 10%. Well, this is the contribution that you can have to your retirement, and the company will match 10%. So basically 10% you give, company match is 10% as well. Between 30,000 and 60,000, you can save all the way to 10% of that. Company will pay 10% of the first $30,000 and 5% of anything above $30,000. Between 60,000 and $100,000, 10% of the 60K you can save tax-free, and 8% of whatever is above 60K. For the company, that would be 10% of $30,000, 5% of anything between 30 and 60, and nothing after $60,000. Above 100K salary, you can save up to 10%. The first 60K, 8% between 60K and 100K, and nothing above 100K. And company will give you basically nothing. So we want to write a function retirement that takes salary as input, returns saving in your 401k in terms of your contribution, company's contribution, and total saving. So I'm gonna put this on this side, and I'm gonna open MATLAB on the other side. I'm gonna open up a new script. Of course, when you want to write a function, you have to have a new script. I'll put the script over here, right next to my, because this is basically my algorithm. I need this, right? So I need to have this next to my script and function. So function starts with a function. The output, as it is asked for, my contribution, company's contribution, and total saving. The name of the function is already given to you. Retirement is the name of the function. Input is salary. Starts with if it is less than $30,000. If salary is less than or equal to $30,000, my contribution is basically 10%. 10% is 0.1, right? So 0.1 times salary is my contribution. I put a semicolon just to make sure that it doesn't write to the screen. That's annoying. Company's contribution is again 0.1 times salary. So this is if it was less than $30,000. If it is more than $30,000, so else if, I would, in the class I would ask if do I need to put salary more than $30,000 or not. And since we don't have the audience here, I would say, when we are using else, it means that the salary is already not less than or equal to $30,000, so it's going to be more than $30,000. So basically, I don't need to say salary more than $30,000 because this else already does the job for me. Else if salary is less than or equal to $60,000 now. My contribution is again 10% of the entire salary, so 10% of salary. And company's contribution is 10% Of the first $30,000, it is already more than $30,000. So we have the 10% of $30,000 is guaranteed. 5% of whatever is above $30,000. So 5% is 0.05 times whatever is above is basically salary minus $30,000, right? So that's whatever is above $30,000. Else if, again, I don't need to say else if salary is more than $60,000 because else will already do the job for me. You can, you don't have to. Salary is less than or equal to 100K. My contribution is 10% of the first $60,000, and again, I already have $60,000. Remember, this is more than $60,000. And 8% of whatever is above 60K. And company's contribution is 10% of the $30,000, the first 30, 5% of the second $30,000, because that's whatever is between 60K and 30K, right? So that's $30,000 right there. And nothing above 60K. So that's about it. And else, my contribution. So else, I don't have to put else if anymore because it is more than 100K and you can go to millions of dollars. It wouldn't matter. So that's else only. You don't need an if here. So my contribution in that case would be 10% of the 60K plus 8% of between 60K and 100K. That sits $40,000 there, and then nothing above 100. So that's 100K. 0 times 100K or whatever salary minus 100K. We don't have to put anything above that because that's nothing already. And then company's contribution is 0. And so far we have calculated my contribution, company's contribution, but total savings is basically my contribution plus company's contribution. Now, again, I'm gonna check to make sure everything is correct. Between less than 30K, it's 10% of my salary, both my contribution and company's contribution. Perfect. Between 30 and 60, 10% of the salary is mine. My contribution, 10% of the first 30, and 5% of the rest. If it is less than 100K, 10% of the first 60K and 8% of whatever is above 60K. So that's perfect. And then company's contribution. See, I want to draw your attention to this. Again, see this wiggly thing? Because what I have is my contribution, company's contribution, total saving. See what happens here? Instead of company's contribution, COMP, I have COM. So that's giving me the error already here. So I need a P here. Perfect. That would be 10% of the 30K, 5% of anything between $30,000 and $60,000, which is basically $30,000, and nothing above nothing above 60K, so that's plus 0. Then if my salary is above 100K, contribution is 10% of the 60K, 8% of the 40K, that is between 60 and 100K, and nothing above 100K, so that's plus 0. And company's contribution is basically 0. So total saving is my contribution plus company's contribution, so that's done. The function is done now. I would save this, and I will not change this names. Remember, this name should remain unchanged. it's gonna go into this folder, Week 3 video, which is where I want it to be. But in order, just want to make sure that when you want to evaluate this function, you're gonna make sure that this function is already within your current folder. That's the most important part. So question 1 is done. Question 2 is asking, use the function retirement in a while loop to determine how many years should you work with a salary of $45,000, given the fact that you are entitled to a raise of 1% in salary each year. You want to save $50,000 in your saving plan. And there is a hint here. You would need to define the threshold for the while loop based on the total of $50,000. So basically you want to work each year, you have a salary, you will accumulate your savings until you get 50K. You will also need a counter variable defined before the while loop, which in turn which increases within the loop. All right, so let me open up a script. This is now again, I do clear CLC for each of my questions. Remember, salary starts at $45,000, equal to $45,000. So far you haven't worked at all, so counter is equal to 0. Basically, this is the start of your work, you haven't worked yet, so you start with a counter of 0. And then what also is important is, you know, the function, what it gives you how much of the salary of each year you would save, right? So you need to add that saving to an account. So let's call the variable account and set it as 0 because you haven't worked yet, you don't have any saving. So we set account at 0. Now what we say is how many years would it take for your account to go above $50,000? So what I put here is while account is less than $50,000. See, this is important. Account should be less than 50 because while account is less than 50, it will keep running. The moment it goes above $50,000, it would stop. So account should be less than $50,000. You can put an equal sign there, it wouldn't really matter in this case, but we want to stop even if it is $50,000, so that equal sign should be there. Now what happens is that you got to call your retirement function and you got to find out what is your total saving in that year. So salary will go in, total saving will come out. We don't really care about your contribution, company's contribution. So if you want, you can keep them. If you don't want to have them at all, you can just replace them with tilde. Tilde means the first output argument is not important, the second output argument is not important, the third output argument is what we care about. And then account becomes your previous account, so whatever you had the previous year plus total saving, so whatever is added this year. So this is now the amount of money that you have in your account. Now remember, you calculated your retirement, you added that saving to your account. Now we want to go to next year. Next year your salary will increase 1%. So salary is equal to salary plus 1%, right? 1% times salary. So this is similar as if you had salary is equal to 1.01 times salary, isn't it? When you put this comment sign or a percent sign, well, when you put this percent sign, this becomes a comment. Whatever is in front of this percent sign is not going to be evaluated. So this is like a comment. It's not going to be evaluated, so that's not important. So your salary is now increased. The other thing that happens is that 1 year has passed since the previous calculation. So counter will increase 1 year, right? So 1 year has passed. You had your saving from retirement. You added to your account. You increased your salary. Now you increase your counter. Now the counter becomes 1 because year 1 has already finished. Now I would end it here because this is going to do the job for us. If I evaluate this, if I look into my MATLAB, I see counter is 6. So after 6 years, you have a retirement account of $50,000 and $50,526. So that's above $50,000. So with 6 years, you can get there. That is what the question is asking, basically, and that's about it. I'm gonna save this under homework 3. Done. Now we can move to question 3. So for question 3, the question is asking, let's say you want to park your car in the Boise Airport parking structure, and you have to select one of the two options. Either it's short term, which is option 1, or long term, which is option 2. Here is the detail of how much you will be charged based on each option. So if you choose option 1, each first 20 minutes will cost you $3, and each additional 20 minutes, or even fraction of 20 minutes. So if you have 21 minutes, that means that you had 20 minutes, so that's $3, and then you have another minute, which is within the section of second 20 minutes, so that's another $1. 3 plus 1 is $4. If you have 45 minutes, you have 2 sections of 20 minutes, so that's 3 first, 1 for the second section, and then you have another 5 minutes, which goes to the third section and becomes another $1. So that would be $5. So what happens is that you cannot go above $20 for each week. So if you have, I don't know, if you have 20 hours, 20 hours is each hour is 60 minutes. 20 hours is 120 minutes, and 1200 minutes. 1200 minutes divided by 20 is 60 sections of 20 minutes. So if you want to add up, you'll have a $3 charge for the first section and $59 charges for the next 59 sections of 20 minutes. So that's 59 plus 3, that would be 62, but the maximum that you can charge for a day is $20. So you cannot go above $20. So basically, although it's $62, you can only charge for 20. And not only that, if you have several days, if you have 5 days, 5 times 20 is 100, but you cannot charge more than $60 per week. So basically, you have these constraints of daily and weekly charges that you have to take into account when you're writing your function. And option 2 is the long-term one, which is hourly. First hour will cost you $5, and each additional hour will cost you another $2. Daily maximum is again $20, and weekly maximum is $60. Similar to previous one. Before jumping into solving this question, I would like to draw your attention to 2 built-in functions. Let me do clear and CLC, get rid of everything that's here. The first function is ceil. If you do ceil of 1.4, you'll get 2, because ceil will give you the upper value of whatever you inputted in terms of an integer number. So 1.4, the upper integer is 2. Ceil of 1.1, that's again 2. It doesn't matter what that so it's not like rounding. It goes upper anyway. When you use ceil, it will go to the next integer value. There is another function floor which goes back to the previous integer value. If you put 1.1, you'll get a 1. Floor of 1.7 is again 1. So see the difference between ceil and floor and rounding. Basically, if this 1.5 or above, it goes to 2. If this below 1.5, it goes to 1. But ceil and floor are different. Ceil goes to the next one, floor goes to the previous one in terms of integer values. Now, what happens here is that, first thing that you would do, you'd have to find how many weeks are within your minutes, because you cannot charge more than $60 per week. So find out how many weeks you have, separate them, and if you have 2 weeks, that's 2 times $60, done. Then you cannot charge more than $20 per day. So remove your number of days, and if you have 3 days, that's 3 times 20, $60, that's done. And then find out how many sections of 20 minutes you have left. So again, it asks you to write a function called parking rate that takes option and minutes as input and return parking charge. So I open up another script. I want to write a function, so I start with a function. The output is charge. Since I have only one output, I don't need the brackets, but I put it there anyway. I call my function parking rate, and the inputs are minutes and option. If option is 1, we have one set of situations. Else if option is equal to 2, see, they have 2 equal signs because we are comparing. Then we have another set of situation. But even before I go into these options, I have to separate my number of weeks and my number of days anyway. So I just do it beforehand, so I don't have to repeat writing the same commands twice. N days and N weeks. N weeks. Now we got to go back to the ceiling and floor commands that I just talked about, right? So number of weeks. Let me go back to this. CLC clear. So let's see how many minutes is there in a week. So minutes is equal to we have 7 days. Each day is 24 hours, and each hour is 60 minutes, right? 7 days, each day is 24 hours, each hour is 60 minutes. So that's the number of minutes that are within each day. I guess this is the number of minutes within each week. So let's say I have 10,080 minutes. That means I have 1 week. If I have 10,120 minutes, that means I have 1 week and 40 minutes, right? So if I add 40 minutes to 10,080 minutes, that is 40 minutes above 1 week. Let's make it even easier. Let's go with 10,000 and 100 minutes, which is basically 1 week and 20 minutes. So 20 minutes plus 1 week is 10,100 minutes. If I use floor of this divided by number of minutes which is available in each week, which is 10,080, you will see that it will give me 1, which is 1 week basically. Now if I have 2 weeks and 20 minutes, it's like I have 2 weeks plus 20 minutes. And if I use floor again, floor of 2 times this plus 20 minutes, so I have 2 weeks and 20 minutes. Floor of that number of minutes, whatever it is, divided by 10,080 minutes, which is the number of minutes in each week, it will give me, oh, well, I'm making a mistake right here. I need a parenthesis over this, right? I have 2 weeks and 20 minutes divided by the number of minutes in each week. I'll have 2 weeks. So this is how I can separate my number of weeks. Number of weeks would be floor of minutes, whatever it is that comes in, divided by, although I know that's 10,080 minutes, I'm just going to write it again. 7 days, 24 hours, 60 minutes. So that's the number of minutes within each week. And again, I use this parenthesis to calculate this number because this is the number of minutes within each weeks. When you calculate your number of weeks, you got to separate that number of weeks from the number of minutes that you had, right? So see here, we had 2 weeks and 20 minutes. So if I want to separate the number of weeks, so if I want to just remove the number of weeks, I have 2 weeks and 20 minutes. I remove those 2 weeks because those are $120 done. I have to only charge for 20 minutes. So what I will do is, this was the number of minutes that I had, right? This was the number of minutes that I had. Minus number of weeks is what? 2. So 2 times, and number of minutes in each week is what? 10,080. So if I do the total number of minutes that I have minus number of weeks times number of minutes within each week, then I can separate that I have 20 minutes left of that, number of minutes that I had before. So I'm now going to update my minutes by doing minutes minus n weeks times how many minutes is in a week. I'm just going to copy and paste it right here. So what happens is that, first of all, it will find how many weeks is within my minutes, right? And then it will subtract whatever number of minutes within those weeks from the number of minutes that I had. So if I had 2 weeks and 20 minutes, now my minutes become 20 minutes. That's perfect. Now I have to separate number of days. So each day is 24 hours. Each hour is 60 minutes. So if I do minutes is equal to 24 hours times 60 minutes, I have 1,440 minutes within each day. If I have 4,000 or if I have 1,460 minutes, that means I have 1 day and 20 minutes, right? So again, similar route, floor of 1460, the number of minutes that I have, divided by 1440, number of minutes within each day. I have 1 day and I have 20 minutes on top of that day. If I have 3 days and 20 minutes, it's like I have 3 days, each day is 1,440 40 minutes plus 20 minutes. So I have 3 days plus 20 minutes in the number of minutes that I have, and I divide that by 1440 and take floor of that. That again will give me, I have 3 days in here. So I'll copy and paste this right here, floor of minutes divided by, so this is the minutes left, right? So we updated the minutes here, and then we want to remove the number of days from those minutes now. So minutes divided by 24 hours, each hour is 60 minutes, so this is the number of minutes within each day. This will give me the number of days. Perfect. Now again, I have to update the number of minutes because I removed the number of days from them. I have to update them, right? So minutes is equal to minutes minus number of days now, instead of number of weeks, times 24 hour per day, 60 minutes per hour. So this is now my updated number of minutes. So I have my number of weeks, I have my number of days. Now I go back to my question and I see, all right, now I can go to option 1 and option 2. Option 1 says each 20 minutes will cost you, well, the first 20 minutes cost you 33 bucks. Well, the first 20 minutes cost you $3, and each additional 20 minutes or fraction of 20 minutes is $1 charge. So basically what we are looking for right now is we are looking for the number of fractions of 20 minutes, right? So I call it N20. That instead of, so what happens here is that, remember we talked about this, 20 minutes is $3, 21 minutes is $4, right? So that 1 minute is gonna cost you another fraction of 20 minutes. So basically instead of using floor now, I'm gonna use ceil. So if I have ceil of 21 divided by 20, because each fraction of 20 minutes is, you know, the first one is $3 and each extra one is $1 extra. So I have two fractions, each one of them 20 minutes. The first one is $3. The second one is $1. If I have 41 minutes, I'll have three fractions. First one is $3, second one is 1, third one is 1. So I have a total of $5. So I calculate this as ceil of minutes divided by 20. That's how many fractions of 20 minutes I have. Now, the cost the total cost is basically what? So each first 20 minutes is $3. So that's basically 3 plus. So the first one is 3, and 20 minus 1 times 1 is each additional 20 minutes. So that's cost for the fraction of 20 minutes that I have. Now the issue is this cannot go above $20. Remember we talked about this. If we have about 20 hours, that's going to be like $62, which we cannot let happen. So what we'll do, we'll use the function minimum here. So minimum of whatever this is, and $20, right? So we cannot charge more than $20 per day. So if this charge is more than $20, we can just charge $20. If this cost is less than, so if we only have 5 minutes, which is $3, we cannot charge 20. But the minimum of 3 and 20 would be $3. If this goes above $20, so if this becomes $62, minimum of 62 and 20 becomes 20. So we only charge for $20. There is one issue here that I will come back and I'll discuss. The other thing is, then we have to charge for the number of days. N days times 20 bucks. Then the issue is if you have 4 days, then 4 times 20 is 80 bucks. You cannot charge more than 60 bucks per week. So again, we are going to use the function minimum. Minimum of n days times 20. So how many days you have times 20 and 60. You cannot go above 60 with this. So if you have 1 day, that would be 20 bucks, minimum of 20 and 60 is 20, so 20 is going to be selected. If you have 5 days, 5 times 20 is 100, minimum of 100 and 60 is 60. So that will give you exactly what you need. This is perfect so far. And then you got to charge for the number of weeks. There is no maximum whatsoever on the number of weeks that you can charge. So n weeks is going to be n weeks times 60. Done. Then there is an issue now. Let's say, let's say you parked for 2 weeks straight and 0 minutes, right? So 2 weeks and 0 minutes. What happens is that this will cost you, this 3 is going to be there anyway, right? So 3 plus n20 is going to, so 2 weeks, so n weeks is going to be 2. Minutes is going to be 0, right? It's 2 weeks and 0 minutes. So the remainder of the minutes is 0. N days is going to be 0. Minutes is going to be 0. N20 would be 0 divided by 20. Seal of that is 0. Perfect. Let's come here. Minimum of 3 plus 0 minus 1, so this becomes minus 1, times 1. So this becomes minus 1. 3 minus 1 is 2. Minimum of 2 and 20 is 2. So you have a $2 extra charge if you only parked for 2 weeks. So this is a little troublesome. But what we can do is if n20 is more than or equal to 1. So if it is 1 or more, then this is perfect. If it is not, else cost is, again I copy and paste this, but we don't have this first part anymore. We only have number of days charge and number of weeks charge, and that's about it. Done. So this is the first part. I'm gonna use tab here to be clean and everything be on the same order. For option 2, that's hourly. Let me go back to the question very quickly. The first hour is $5, each additional hour is $2. So if I say NH for n hours, that would be seal. Again, I'm going to use seal, right? So because if there's 1 hour and 1 minute, 1 minute will cost you 1 hour, right? So I'm going to use seal of number of minutes divided by 60, because 60 is how many minutes exist within each hour. So if I divide it by 60, that will give me the number of hours. Again, I'm going to have a similar situation as here, because I'm going to charge $5 for the first hour. What if my first hour doesn't exist? What if I only parked for 2 days straight? 2 days straight, no number of hours extra, so I cannot charge it. So what I'm going to use is I'm going to copy and paste that. Instead of n20, I'm going to put an hour, and h is more than or equal to 1, so it cannot be 0 now. Then I charge $5 for the first hour, and for each additional hour I'm going to charge $1. I'm just going to go back. Oh, each additional hour is $2 actually, so I'm going to multiply this by 2. So an hour minus 1 times 2, and I cannot charge more than 20 bucks per day, so I'm going to need this. Similar situation for the number of days and number of weeks as we discussed before. So this is now perfect. You have your cost, and now what I noticed is that we call our thing cost, whereas the output is charge. So that's not gonna look good. I'm gonna copy this. I'm gonna replace cost with charge, So we have our output defined. So this is how you're gonna write your parking charge. Again, this is a function. You're gonna save this, and then it's gonna be your file name. Don't change this, and this is your function. Perfect. It didn't ask me to evaluate this, but I'm gonna add it myself. Let's say I parked for 21 minutes, right? 21 minutes means I should be charged for $4. Let me evaluate this and see if I'm going to be charged $4 or not. Again, CLC and clear, get rid of everything. Number of minutes is 21, and I'm going to use option 1. If I evaluate this, charge should be $4, which it is. Perfect. If minutes is now, I don't know. Let's say we have 1 week, 1 hour, 1 week, 1 day, 20 hours. So minutes now becomes 1 week, which is 1 times 7 days, 24 hours, 60 minutes. 1 week, 2 days, each day is 24 hours, each hour is 60 minutes. Plus 20 hours, which is 20 times 60 minutes. This is 1 week, 2 days, 20 hours. So 1 week is going to be $60, 2 days is going to be $40, so 100 so far, and then 20 hours, it's going to go above $20, so you got to charge another $20 from this, so we have 120. Now if I evaluate this, I don't have to redefine my option anymore, because option is already 1, so I'm just going to use the same thing. Do I get $120? Yes, so perfect. It's working perfectly. Let's go with option 2 as well. So I change option now, but I'm going to use the same number of minutes now. So it's 1 week, 2 days, 20 hours. Same situation happens here. You have $60 for the week, $40 for the days, and then 20 hours is going to be more than what you can charge for a day. So that's another 20. So it sums up to 120 minutes. So if $20. So if you evaluate this, you again get $120. If you only have, well, let me do this. Let me just copy and paste this here. If you only have 1 week and 2 days, you're going to be charged for 60 plus 40, 100, right? 0 hours. That's the if statement that we've defined. So that gives me $100 right here. If you have 1 week, 2 days, 1 hour, it's going to be $105. And that's what we get. So basically our function is correct. Perfect. All right, now let's continue on with question number 4. Which of the following loops will not stop? So if you remember, we talked about this. For loops, there's always a starting point, there's always an ending point. So it will loop between, like for this one, it will loop from I equal to 1 to I equal to 10 to the power of 6, which is a million, but it will stop. This one is saying a equal to 0, then while a less than 1, a is equal to a times 1,000, and while this statement is correct, it will keep running, right? So this is 0, 0 times 100 is 0, then again 0 times 100 again is 0, again 0 times 100, so it will always remain 0, so 0 is always less than 1, so it will not stop. If you want me to try this, I'm gonna run it for you very quickly. Again, clear and CLC. Well, okay. So as you can see, it's always busy. Like it keeps busy because it's running, and it will never end. So it will crash my computer. So what I will do, I'll hold Control and press C. Control C will end the computation, whatever it is. A is equal to 1. Now while a is less than 0, a is equal to a times 2. This one will never start because 1 is not less than 0, so it will never start in the first place. A equal to pi, counter is 1, s is 0, while s is less than or equal to 1, which it is. S is cosine of a times counter and counter plus 1. Cosine is always less than or equal to 1. So this one will not stop either. Now let's go to question 5. The question 5 says write a function called factorial, like with e, because factorial is already a built-in function. We don't want to mess that up. So let's write our function with e rather than a. It will take the value n as input and return n factorial as an output. So again, open up a new script, function, and then name of the output, I don't know, nn equal to factorial of n. What we need to do, it really didn't say whether to use what to use, but we can use while loop, for example. What we'll do is first, these are multiplications. So for multiplication, always in a loop, 1 is a neutral value for multiplication and 0 is a neutral value for summation. So if you want to add things up, you can start with 0 because that wouldn't have. So 0 plus 2 will become 2, and then 2 plus 3 will become 5. That 0, that starting point, really doesn't have any impact on the sum if it is 0. And then similar for multiplication, if you start at 1, then that's always good. So that's wonderful. So nn, the starting point is 1, while n is more than or equal to 1. So while n is more than or equal to 1, we keep doing this, and you'll see how this will pan out. N times n, and n is equal to n minus 1. So what happens is that it will take this n, it will start at 1, let's say n is 5, while n is more than or equal to 1, so 5 is more than or equal to 1, perfect. nn, which used to be 1 times 5, nn becomes 5. N becomes 5 minus 1 is 4. 4 is more than or equal to 1? Yes, perfect. nn was 5 before. 5 times 4, 20. So it go all the way to n equal to 2, then this becomes n equal to 1, comes here, more than or equal to 1, yes. Then whatever nn was times 1, it doesn't change. Then 1 minus 1, it becomes 0. Comes back, 0 is more than or equal to 1? No. So it's going to stop right there. I'm going to save this and I'm going to evaluate this function. very quickly for you to see. I'm gonna close this one. I'm gonna come here. I'm gonna use CLC and clear always. And then I'm gonna use the function factorial that I just defined. A 3 factorial should give me 6, right? So if I evaluate this, I get a 6. If I evaluate factorial of 4, that's 4 times 3, 12, 12 times 2, 24. So I should get a 24, which I get. If I evaluate factorial of 5, that's 5 times 24, which is 120. So this function is correct. Now let me move to question number 6. Number 6 and 7 might be a little confusing. Just let's focus on each question separately, and let's solve the question separate. Question 6 separate from 7. So let's start with 6. Natural log of 2 can be estimated through an alternating harmonic series defined as summation of k from 1 to infinity minus 1 to the power of k plus 1 divided by k. Write an M file altharm.m in which a for loop is used to iterate over k from 1 to 100 and to calculate the alternating harmonic series values for each k and assign it to Lk of 1. So if k goes from 1 to 1, it means that if like from 1 to 1, that's negative 1 to the power of 1 plus 1 divided by 1. Then k becomes 2, it becomes 1, what was before, and then for 2, it's the previous one plus negative 1 to the power of 2 plus 1, 3 divided by 2, whatever it is, plus the previous one. Then Lk and 2, so basically row k column 2 should be assigned as log of 2 in each iteration. Log of 2 remains constant, so basically the second column is always log of 2, has a certain value and wouldn't change. See at what k, so what value is the k, the alternating harmonic series value, the first column, is approaching log of 2, which is the second column. Plot the first column of L with a black solid line and use hold on to plot the second column of L with a blue line in the same figure. Alright, let me open up a new script because that's what it's asking me. I'll save this as alt harm. This is a script, it's not a function. I will always use my start my scripts with CLC and clear. What it says is that for k from 1 to 100, the first column of k is basically the harmonic series. The harmonic series is what? Is negative 1 to the power of k plus 1 divided by k, but that's the summation of all elements. I'll get to it in just a second. To the power of k plus 1, and that's divided by k. And the second, this is not complete, so hold on. The second column is always log of 2. So if k is 1 now, if k is only 1, this is okay. If k is 2, it means that k1 should be added. So k equal to 1 is this, plus minus 1 to the power of 3 divided by 2 added to k was 1. So basically, if k is 1, then this is perfect. Else, it is the summation of all the previous elements. So that would be L of k minus 1 comma 2 plus the new element. So see, this is the summation of all elements, right? So k equal to 1, we have an element. K equal to 2, we have an element. K equal to 3, we have an element. We are going to add all those elements up to get the summation, right? So if my first element is L of 1 and 1, which is the first element, then perfect. Then the second element, L of 2 and 1, would be L of 1, oh, L of 1 and 1, L of 1 and 1 plus negative 1 to the power of, now k is 2. So basically element 2 plus whatever was saved in the first round. Now for the third round, L of 3 and 1, whatever was in the second round was the summation of the previous two elements, right? So the previous two elements plus the new element, which has a k of 3 now. For a k of 4, the fourth element of L is basically the summation of the three element of k1, k2, k3 plus k equal to 4. So you'll keep adding them up as you proceed. And L of k comma 2 is always log of 2, so that wouldn't change much. And I would do end here. One thing that you know, I don't like it. One line is here, one line is here. This is a little tricky. I can always use this option here, indent, right? It will keep them in the same line. See, these two are in the same line. This is in the same line as this. So this is basically tidy up the code a little bit. So select all, either hold Control and press I, or use this bottom right here, which is basically the same thing, indent. What it says is to plot the first column. So you want to plot the first column, so all the elements, so all the rows and the first column, and then use hold on and plot the second column now. The only thing is, this was asked to be black solid line, so we put K, and this was asked to be a blue line, which is again solid line, so this is blue now. If I plot this, let's see what happens. As you can see, you know, it starts, so the blue line is log of 2. Log of 2 is what? Almost 0.7. So log of 2 is almost 0.7. It's always this blue line. You can see the black line is basically these harmonic series, starts to fluctuate, but starts to merge to what we have here. But still at element 100, at k equal to 100, still it's not quite the same. So I go back, well, this is factorial, I just don't need it. I go back, instead of 100, I put 1000, and I run this again. And you can see that at 1000, it will keep oscillating, but it will get closer and closer to this value. You know, this scale is really small, so the difference is not too much. It's acceptable. If you want to even further increase that, you add another 0 and run, and then you will see that they will be the same after a while. They're like the same. Like, see, the difference is really small. Alright, so that's question 6. Now question 7. So again, we are working on this harmonic series, but this time you're writing a while loop that would estimate the number of k required for which the difference between this and log of 2 becomes less than 1e negative 4. 1e negative 4 is basically 10 to the power of negative 4. So I go back to my alt harm script, and I'll do it in the same script. Again, let's forget about question 6. Let's just focus on question 7 now. Question 7 is asking for a while loop, right? This is summation of several elements, and if you remember, we just talked that the neutral value for summation is 0, but we probably don't even need that. So I start with k equal to 1. I just define the first element of this, and I go with a variable name, I don't know, alt h, I don't know, alt h is equal to the first element. If k is equal to 1, it goes from 1 to 1, negative 1 to the power of 1 plus 1 divided by 1. So negative 1 to the power of k plus 1, k is already 1 defined, divided by k. Then the issue is, while the difference between this alt h, which is basically the summation of all the elements, while the difference between alt h, and there is an issue here which I'll get back to in just a second, and log of 2 is more than 1e negative 4, we want this to keep running. The moment that the difference between the two becomes less, it should stop. Now, k was 1, we calculated alt h. Now we make k equal to k plus 1, and we calculate alt h again. So alt h is basically previous alt h, whatever it was, plus the new element. Since k is increasing, this new element represents the new k values. And so while the difference between these two is more than 1e negative 4, it will add k, it will calculate the new element, and it will add it to alt h. So that's how it works. But the issue here is, if this goes negative, we are going to have an issue. So when I only care about the absolute difference between two values, which in this case I only care about the absolute difference, right? So I use absolute value. ABS is absolute value. ABS of negative 2, absolute value of negative 2 is 2. ABS of 3 is 3. So the absolute value is basically, there's no sign for the value, it's just the absolute. So this, as you can see, as you would probably remember, I don't know if I have the figure or not, like in this figure, when this is oscillating like above and below, at some point the value of alt h is below this blue line. So the difference is negative. We don't want that. We just need the absolute value. So we're going to use the absolute value here. So again, I start with k equal to 1. I calculate that alt h. That is negative 1 to the power of k plus 1 divided by k. So at k1 there is no previous element. So that's it. When k becomes 2, alt h will become the previous alt h plus the new element. Then k becomes 3, then the previous alt h plus the new element. So it will keep looping until this alt h merges to log 2. At some point the difference between the two becomes less than 1e negative 4, so it will stop right there. So if I evaluate this, you'll see that k is 5,000. So when k is 5,000, the difference between alt h, so alt h, the last alt h that we have is 0.693, and log 2 is 0.69931. Alt h minus log 2 is 9.9 times 10 to the power of negative 5. Again, this negative sign is not important because that goes above and below the value, and we don't really care about that. We just care about the absolute value. So this is 10 to the power of negative 5. We wanted this to be less than 10 to the power of negative 4, which this is, and everything is perfect. So with 5,000 iterations, we reached there. Now question 8 asks, use for loop to calculate sum of the elements of vector x. As you remember, let me go back to this. Alt H is done. I'm going to close this. Let's go back to this. Clear and CLC. The question asks, use a for loop to calculate sum of the elements of vector x. Let me just copy and paste vector x into here. If you remember, we could have just done sum of x, right? Sum of x will just calculate the summation of all elements in x for me, and life is beautiful. But guess what? That's not what we want here. We want you to use a for loop to calculate sum of x. Back again, if you remember, we talked about what is the neutral value for sum. That was 0, right? So if you use 0, 0 plus 2, that becomes 2. So that 0 doesn't have an impact on the summation. So I call my variable name sum x, and I started with 0. What I will do, I will use a for loop. But how many iterations should I go? The iterations is basically the number of elements in x. What are the number of elements in x? Number of elements in x you can calculate, or you can estimate using length of x. Length of x is 8 because we have 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. So for I from 1 to length of x, or you could have just written 8. Wouldn't matter. This is more general now. For this, sum x is equal to previous sum x plus x of I, and this will give you the summation of all the elements. Let's see how it works. For I equal to 1, sum x was 0, right? Sum x was 0. 0 plus x of 1, which is 3. So sum x becomes 3. So now sum x is 3. We go to end. Go back 4. I becomes 2. Sum x was 3. Remember, 3 plus x of 2, which is 8. 3 plus 8, 11. So sum x becomes 11. I becomes 3. 11 plus 14 becomes 25. So it will continue doing this until I becomes 8, and the summation of all these elements will be added to 93. Now let me run this. Okay, sum x is not defined because I had to choose from here. So the variable sum x has a value of 263, which is equal to basically using sum of x. So we wrote a for loop that will calculate the summation of all elements in x. Now, question 9 says use a while loop to perform the above tasks. So basically now instead of a for loop, we want a while loop. But how can we do that? Well, it's not too hard. Let me go back here. Again, I use clear and CLC. Now, remember for loop, we went from 1 all the way to length of x. For while loop, we don't really have that counter. For while loop, what we'll do is you'll say, all right, so how many elements are available in x? nx is equal to length of x, right? There you go. While, and then before going there, sum x1, I start with 0 again because for a summation the neutral value is always 0. While nx is more than 0, while nx is more than 0, it means that still we have some element left in x. Sum x1 is equal to sum x1 plus x of nx, and nx is nx minus 1. I'll explain this in just a second. So let me also just copy and paste this x into here, because when we use CLC and clear, everything else is gone. We don't want that. We need to define x again. So x has 8 elements, and x becomes what? 8. So if I just evaluate this, you will see that nx is 8. And sum x, you got to start with a neutral value, so sum x1 is 0. While nx is more than 0, so while 8 is more than 0, so that's correct. We should go through the for loop. Sum x1 is equal to sum x1, which was 0 before, plus x of what? X of 8. So it starts from 93 now. X of 8 was 93, so sum x1, 0 plus 93 becomes 93, and nx now is what? 7. Goes back. 7 is more than 0. Yes. 93 plus 56. So 93 plus 56 becomes sum of x1. And then nx used to be 7, now becomes 6. So it goes all the way to 1. So it will add this to this, and then the summation of both of them will be added to 45. And then summation of all 3 will be added to 25. And then summation of all these 4 will be added to 19. It will go all the way to here. And x is 1 now. It will add x of 1, and then 1 minus 1 becomes 0. 0 is more than 0? No. So it will stop right here. Now let's evaluate this and see if it's going to work or not. If I do look at sum x1, that's 263, so that does the same job as the previous one. Perfect. We solved all the questions in week 3, and I'll see you in class.